Okay, last time we added code which allowed agents to patrol a series of waypoints using a nav mesh. Let's kind of revisit this real quick. See, one agent is walking, and several of them are standing around. I'm going to stop this and let's make some adjustments here. First of all, have them go to the first waypoint, and then we'll start it. And I'm just going to up the walk speed, and we can see him go from one waypoint to another. I'll zoom out a little bit. And I'll have him go a little faster here. I can just adjust the speed here. Okay, so that's the original behavior. We never tested the backwards direction here, so I'm going to ask him to do that backwards now. And let's see if that works for us. And we'll have him go in the opposite direction here. Make sure everything's okay. And again, ignore the guys who are standing and skating off into the distance. We haven't worked with that. He seems to run into the waypoints a little bit and does something a little bit silly there, but I think he's ducking around underneath there. So one thing we might do is to go to the script here, and let's change let's make a property for the distance, like float, and this will be the waypoint distance. I'm trying to think of a good name for this here. I'll just call this near waypoint equals, right now it's at 2.0f is its value here. Now earlier I said that I don't like hard-coded values, and you kind of see why, because near waypoint. I want to up this a little bit, but I'm not sure how far to up it, if that'll even make a difference. So we can see here that there's a near waypoint of 2, and I will up that to 5. And then I'll take my walk speed and crank it way up here. Okay, see, that looks a lot better there. So I think some of the weird things that I was seeing was that the waypoint turn was probably within the yeah, that looks better. So having that value at around 3 gives me a little bit better look to it. And you can't, and if you can't see it too well from that view here, let's zoom down here and take a look at it. That last waypoint, remember I messed around with its scaling here. So waypoint 4 has been flattened, and I'll put it back the way it was before. In fact, I can, well, there. That should be the same scaling that all the other waypoints have. All right. Okay, so what we've seen here is that the running or the circular patrolling looks really well. Looks really good. Okay, so patrol forwards, patrol backwards. If there was any little hiccup there, it was probably because we were too close to the waypoint, and I will reset this value down to 3 as a good value. All right, let's take a look at some of our other options that we have in our patrolling. And in particular, I want to come down here to take a look at patrol. Linear we haven't checked. Okay, linear walks down the list, turns around, and heads backwards. That code's in there. So let's see if this works. If I take and make him linear, and then I'll have him patrol forward. So he should visit them in order and then turn around and head backwards. And just to be doing here, let's up his speed. Clearly there's a relationship between the speed and the waypoint distance. So if I make it too fast, he can actually collide with the... Okay, so we can see him hitting a waypoint, turning. And just going back and forth. Now there's really not a whole lot of difference between the patrol forwards and patrol backwards when I set it. We should probably be able to see it change here. Yeah, so it's automatically changing when he hits the end. So whether we start going increasing order or decreasing order, it doesn't matter. Okay, so this is useful if we have if we wanted guards to be patrolling along a path. We could set up a series of these waypoints and they would just walk down, turn around, and come back. That's another behavior there. Okay, we have circular, we have linear. I think that's all that's coded right now for these guys. We have random, so let's take a look and see what we're going to have to do with random. Random's not a hard thing to do. We can gather what that's going to be. It's going to be using a random number generator to find a point. So let's come down here, and what we're going to do is look for just reassign current waypoint equals, and then Unity engine dot random. Oops, I misspelled that. Of course, rather than letting me just back up, dot and then range, and I'm going to give it a range here of, and then I have to give the minimum and the maximum. So 0 and waypoints dot length. Okay, and then I want to set the destination equals waypoints dot or not dot arrow current waypoint dot position. That's how we always set our destinations. And so that's just going to pick one of the waypoints, go to it, and then pick another waypoint, all at random. Let's see what that looks like. Oh, just a second. It's random. Okay, the idea of forward and backward doesn't matter at this point. Doesn't make any sense because there's no forward and backward on random. There's nothing to prevent you from picking the same waypoint as your destination again, although you would probably just immediately reach it and pick a new waypoint. And with 4 waypoints, there isn't a whole lot of variability here. Now, if we had like 10 waypoints, you'd see a lot more randomness going on in here. But this is certainly picking random waypoints and going there. And you can see how useful this might be in a large scene. It's not exactly random wandering, but if I turn these waypoints off just for the sake of this, this is what we see. See, the positions are still there, the waypoints are still there. They're just not visible. And they don't need to be visible, they just need to be in the array. Now I'll stop this. Note that all the orcs have the same behaviors the same set of waypoints. So if I put this one at random and this one at random, now this one here seems to have a little bit of an issue there. Why is he not moving? There's no animation controller assigned to him. Why is this one has no animation controllers? Let me stop this and update the prefab. Click on this and click on this. This is not using the same prefab? It's possible that it isn't. Okay, so what I'm going to do is I'm going to take the where is that walk speed here? Up the walk speed for this guy. Up the walk speed for this guy. And then for this guy, up the walk speed. You don't seem to collide with each other either. And that's something we might want to look into. But that's this is a little bit more complex pathing behavior than we saw before. And I can just take one of these orcs and switch them from random to circular. And we see the one going counterclockwise. That's this one here labeled orc. Well, I'm sorry, it's the one that's highlighted here. These orcs are still going random. And this one's going circular. I'm just going to watch these guys for a little bit just to see. Okay, I'm convinced that the random guys are not following each other. They seem to for a little while, but with only 4 points, the chances of picking the same random values are well, 1/3 each time. You have 3 other possible points to pick. So you can have a number of coincidences where they appear to follow each other, but you know, the 2/3 chance that it won't keeps growing and growing. Okay, so I'm convinced that we've got those behaviors there done. Now let's go back and look to see. Those are all of the patrolling behaviors, I think. Circular, linear, random. Stand is going to use a little bit of work. Okay, so here I have them standing, and you can see that they're sort of skating along here. I think part of the problem might be that they're all running with a zero friction capsule collider. I hit the wrong button there. I don't know if that's the material that I really want for this. Let me select max friction and see if that does a better job. That's just on one of the orcs. And the one that's selected here does not appear to be skating off there. So I think there's a problem with that max friction there. So I'm going to update the prefab and double check to see that they're all running max friction. And now let's run it again. You'll go into idle animation and they stay put. We'll give it a few seconds to see if they skate off again. Because they didn't start skating immediately. They're on a little bit of a slope. Okay, I think that was fine. There was really no problem with the code-wise, because they had a destination that was set during initialization. So it was whatever their current position is. So when it came time to go into the update behavior, well, nothing was changed there, but the agent destination would still remain their current position. Now, if they got knocked off their current position, you'd think that, if they slid off, you'd think they'd walk back to that point. So I'm not really sure what's going on there, but they were never given a movement command. So that might be a little bit of a game of an idea as well, is that we could give them a movement command and tell them to go with a 0 velocity or something like that. All right, I think stand is fine. Maybe wander is the next place to go. All right, for wandering, we're going to need to have an area to wander in. What I'm going to show you is the very simplest case possible, and that is to define a rectangle, and we'll just wander around within that. Because we can pick a random point within a rectangle or a triangle very easily. When we get to higher order polygons, it becomes a problem, because there's a possibility that they could be concave. Now, a convex polygon, we can talk about it in class, but those can always be decomposed down into triangles very easily by creating a fan, by starting at one vertex and then building a triangle out of pairs of adjacent vertices. And so you can just build a fan walking, say, clockwise or counterclockwise from some point. And that will give you the entire polygon. To pick a random point, you pick a random triangle and then pick a point within the triangle. Well, picking a random point in a triangle is half of the problem within a rectangle. So that's easy. With the triangle problem, you pick a random point within a rectangle, and then you just reflect the point over if it's in the half that's not inside your triangle. That will make a little bit more sense on the board if we did it in class. However, concave polygons become a problem, and it's not worth it my dealing with it right now. What we will deal with is I need a way to, excuse me, still have a little cough here. I need a way to specify the wander area. Okay, so I'll just make it a rectangle and save that off. And let's take a look what it looks like in our okay, so we see X, Y, width, and height. So we can just pick points that way. If you want to know what some of the points are, for example, in our point right here, I can see that 10, -5 might be one wander point. Okay, so I'll just say 10, -5, and then the width is between these two. Okay, so that's about 2. Width over here is about 16. Okay, so it's not exactly a rectangle there, but let's just pick some points here, and 10, -5, make it 10 by 10. Now I have a particular area there, so it'd be X plus 10. Let's relocate these points so that they're on an even grid there. All right, so let's just put them here at 10 and -5. And I want to scan down here to see what their elevation is above the ground. Not sure what that is. This point here would be, let's see if that was 10, then let's make this one 10 as well. And instead of negative 5, let's make this one 15. Okay, so that's 20 distance there. And if this is 10, we'll make this one negative 10. It's 20 off of that. And if this was 15, then this will be 15 as well. And then this point over here would be x coordinate negative 10. So negative 10 and negative 5. Okay, that is a rectangle that's 20 by 20. That makes it a little easier for me to deal with there. 20 by 20. And now where's the base of it here? Let me go back to so negative 10 and negative 10 and negative 5 are the minimum coordinates. Okay, so we can now have a rectangle here that's a 20 by 20 region there. And those waypoint pointers are just there for these other algorithms, but I have a wander area that's been marked out with that. Fine. That's my wander area. Now I want to come down here and find, let's see, I think I defined a wander function, and it's here. So I'll need to pick a random wander point. Well, first of all, anytime we come inside one of our patrols, the first thing it does is to set the agent speed to walk speed. Okay, because he might have been running beforehand. And the other thing to do too is a remaining distance calculation is going to need to be performed. If distance is greater than, and I called it near waypoint. We're not really looking for near waypoint. I'm looking near enough of my destination, and that should be remaining distance. So if we're within that, then we just keep moving. Character dot move. Agent dot desired velocity, and let's see what I said there. I said jump and crouch. Okay, hard coding those values for right now. That's fine. And that's all I need to do for the if case. Else down here, I want to select a destination should be a random wander point. And well, let me see how much work that's going to be. I was going to make that a separate function, but I think I can go ahead and throw it in here. It's only going to be about 2 or 3 lines. So well, let me just include it here, and then I'll split it out to another function later if I need to. First of all, I'm going to use integer coordinates, because I didn't round those to the nearest integer. So that would be fine. So I want new x equals and wander area dot x plus Unity engine dot random. We've seen this before. dot range. Oops. Range, yeah, range. And it's a range from 0 to the integer wander area dot width. Int new z is int wander area dot z plus Unity engine dot random dot range 0 int wander area dot height. Okay, and then I'll create a vector 3 position equals new vector 3 new x 0f new z. Okay, now I set the height to 0, and that's not a very good thing to do, but I don't know what the real height is. I want a position that's going to be near the train. Well, it might be exactly on the train. I want it to be near the train. So the position y coordinate is going to be, I'm going to ask the train, oops, I'm sorry, that should be is assigned. And I can just query the train at this point. And I can say active train dot sample height, and then say sample at the position. It will ignore the elevation, of course. And then I want to say plus terrain dot active terrain dot get position dot y plus 1.0f. Okay, so that will give me a POS, and this POS will be, of course, the new destination equals POS. I could have saved myself a line or two by right here. Here, I'll just destination, assign it that way. And since it is managed, it can handle the memory leak by as a result of my just overriding that value there. All right, so now I have a destination, and then I can just say agent dot set destination, and I supply the destination, and that should give me a point within the rectangle. See how well this works. Alright, so he has it there. I want you to wander. Forward's not going to make any difference. Compiler errors. What do we have here? What did I do? Z and X. Let's take a look, see what we did, what I did here. X, and I'll call it Y instead of Z. They're using, because it's a rectangle, they don't have that. Check, see if there's any other usage of wander errors. I think that's enough. Okay. And who knows where he's heading right now. I probably should place a point there. It doesn't look like he. It looks like I've got the distance marked a little different. Here, let me go back in here and make that destination. I either want to print out the destination or make it public here. There. That will mean the destination will show up in our list of variables over here, list of properties. There's my destination. Negative 740. A little curious about that. Let's up his walk speed so he gets there in a hurry. Well, actually, it's X and Z. It's negative 713. All right. I'm not sure what happened with him. Let's double check this. I'm going to pause this, see if I can get an idea of what might be going on. All right. The problem that we have here is that the waypoints were given in those coordinates relative to the start of the waypoints, which I just zeroed, and then moved the orc camp off. So they're all based off of the orc camp base coordinates here. So let's just write down these coordinates here at negative 72, negative 292, and that those will be the base values added to this here. So the x coordinate of negative 72 minus 10 is negative 82. And the y coordinate is negative 292 minus 5 and it's negative 297. That should get the coordinates back into some value here. That should force them to be back inside the rectangle. And we see him moving around. And we see him just pick a new waypoint, get up his speed a little bit. Okay, much better. He is now picking points inside here and changes his heading, randomly moving around inside of the rectangle. Okay, so the code is as I showed you, no changes made to the code. It's just that we have to make sure that the coordinates are in world coordinates and not relative to something else. Now, if I wanted them to be relative coordinates, I mean, I suppose I could always give it a base transform of, for like the orc camp, and tell it to calculate them as an offset from that. And that would be kind of nice if I wanted to up and move the camp around. Okay, because if I pick to move the camp right now, which I could certainly do, he's going to wander out. The reason that these guys here are kind of looks like they're sliding is that they were never given velocities, so their idle animation can continue to run. Okay, so let's stop that and let's think about how to solve that problem, if you want to consider it a problem. And that is that I want my wander areas to be based off of some central point. And let's see where the orc camp is. Orc camp is defined as this point right there. Okay. Oops, I don't want that. Stop. What I'm going to do here is I'm going to add a new transform up here that will be the base point. A public transform wander base. Okay, base point for the wander area. And these are going to be relative coordinates, or coordinates relative to the base point. Okay. So I'll just add in the wander base dot, and let's see, was that X? Dot, and I believe it's X and Z. It's not helping me right here. Okay, and this was a thing, does not contain an X. Is it a capital X? Doesn't contain it. All right, let's take